Sometimes you may encounter equations like this that have a variable not just on one side of the equation, but on both sides. So there's a couple things we need to remember when we're trying to solve something like this. The most important difference is first that we're going to need to use inverse operations to eliminate one of the variable terms. So in this case I can either eliminate 7x or I can eliminate 9x. It's up to you, whichever you choose. Sometimes I think it's easier to do it such that you're left with a positive term, but I also prefer leaving the variable on the left just because that's more conventional. So here you could go either way. I'm going to proceed by subtracting 9x from both sides. If I subtract 9x from both sides, it's going to cancel on the right, and on the left-hand side, it's going to leave me with negative 2x plus 6. Note we now have a more conventional two-step equation left to solve. I want to start with operations further away from the variable itself. So for my next step, I'm going to subtract 6 from each side of the equation. So when I subtract 6 from both sides, on the left I'm left with a negative 2x. On the right I'm left with 10. So all I need to do now is divide each side by negative 2. When I divide by negative 2 on the left, it cancels, leaving me with x, and 10 divided by negative 2 leaves me with negative 5. So there it is. I'm proposing that negative 5 is the answer. Let me just do a quick check to verify. So I want to see if 7 times negative 5 plus 6 is equal to 9 times negative 5 plus 16. And with a couple steps, I can see that each side does turn out to be negative 29. Since they're equal to each other, the equation does work out, and our answer is x equal negative 5. Thank you.